Good morning, class, and welcome to this live lesson recording of Unit 4, Lesson 7, which is all about subtracting numbers that are written in scientific notation. So at the end of Lesson 6, when we were doing adding numbers in scientific notation, I mentioned that basically the exact same way that you add numbers, you also subtract. So the same steps. So again, so just as a reiteration, in order to add or subtract numbers in scientific notation, you have to have the same power of 10. So here we have a 10 to the negative fifth. Here we have 10 to the negative seventh. So we have to convert one of them, and we're always going to convert to the larger of the two. So in this case, it might seem weird because negative 7 seems larger than negative 5 maybe, just because 7 is larger than 5. But in the negative sense, negative 7 is actually smaller than negative 5. So we're going to convert this one. In order to make it a power of 5, we have to move the decimal place over 2 places. So I'm going to rewrite this 7.34. And I have to move the decimal place over twice. So 1, 2. So it's going to be 0.074 times 10 to the negative fifth. So I subtract 2 powers of 10 here in order to add 2 powers of 10 here. So I'm subtracting 2 by moving the decimal place over twice. So then I add 2 powers of 10 here. So negative 7 plus 2 is negative 5, and now we have the same. Okay, so now I'm just going to subtract these, so subtract the coefficients. So 4.66 minus 0.0734, and I'm going to use decimals for that, because off the top of my head, I don't know what that is. So 0.466, might be blocking that, minus 0.07, and I don't remember what the rest of the number was. Whoops, wrong thing. 734. 734. All right, so I get 4.5866. Okay, so it'd be 4.5866 times 10 to the negative fifth, and that would be final answer. So just as a reminder, I just subtracted the coefficient. So I took this number and subtracted this number. So that's, by the way, that's a 0.0734. All right, and then I just left the exponent as the same, the power of 10 the same. All right, so same thing here. Again, we have to find, we have to put them in the same power of 10, and we always want to go for the larger power of 10. So in this case, we have the U.S. national debt was this number in 2021. In 1971, it was this number. Find how much the debt increased. Okay, so to find how much it increased, we subtract them. Of course, this is all about subtracting numbers in scientific notation. Okay, so first thing I need to do is I need to convert this number right here to a power of 13. So again, I'm going to move the decimal place over twice. So it's 0.028, 0298 times 10 to the 13th. So I'm going to rewrite it like this so you can kind of see what I'm doing. So 7.27 times 10 to the 13th minus, and then this would be and I'm going to line this up, 0.0298 times 10 to the 13th. All right, so I'm just going to use a calculator for this. So 2.727, I think I got its numbers right. Whoops. We're just going to get rid of that so I don't keep clicking on it. All right, yep, 727 minus 0.0298 minus 0.0298, double check that's right. Yep, looks good. So it's going to be 2.6972 times 10 to the 13th power. So that is how much the national debt has increased from 1971 to 2021. So that's like 26 trillion probably. I'm guessing that's what it is. Don't really know for sure. I suppose I could actually write the number out, but right now I don't feel like it. So we don't need to know what the number is because we're just leaving it in scientific notation. All right, question number 3. Again, we have to have the numbers both in scientific notation, and it wants the answer in scientific notation. So I'm going to write this one in scientific notation first and then subtract them because it wants to know what is the difference between them. Obviously, this is going to be subtraction because, again, this entire lesson is about subtracting numbers in scientific notation. So I'm going to write this number in scientific notation by moving the decimal place here. So it'd be 1.52 times 10 to the, so how many times do I move the decimal place over? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I was hoping it was the same. Oh, they are 10. This is both 10. Just kidding. All right, so in that case, I can just subtract them. So it says this is a hydrogen atom, this is an oxygen atom, which an oxygen atom would be a little bit bigger. What's the difference between these sizes? So now we're just going to take that and subtract this number times 10 to the negative 10. Okay, so 1.52 minus 1.27, that's going to be 1.52 minus 1 point, I think it was 1.27. No, 1.25, shoot. Back. 1.25. All right, so we get 0.27. Okay, so this is a situation where we have to, can't leave that answer like that. The reason is because, again, in order to be in scientific notation, this number, this coefficient has to be between 1 and 10. So I need to move that decimal place over 1. Okay, so I'm adding a power of 10 here. By moving the decimal from left to right, I'm adding a power of 10, so I have to subtract a power of 10 here. So it's going to be 2.7 times 10 to the negative 11th. So again, I move the decimal place over 1, so then to the right, so then I'm adding a power of 10 here, so I have to subtract a power of 10 here. So that's where we get that number. And that is meters, so 2.7 times 10 to the negative 11th meters. Not sure why we would measure atoms in meters, maybe millimeters, but even then, or nanometers, or whatever smaller than nano, because atoms are obviously very, very small. All right, question number 4. All right, so this is saying platelets and red blood cells are the component of blood. A typical platelet and red blood cell have diameters of this size and this size, respectively. Which component has a bigger diameter and approximately by how much? Okay, so in order to figure that out, we're going to convert this to, actually, you know what? In this case, I think we want this answer to be in decimal notation. So I'm going to convert the 2.23 times 10 to the negative 6th. So I'm going to just move the decimal place over 6 times. So 1, 2, 3, 4, 5, 6. Fill this in with zeros. Okay, so this one has 5 zeros and then a 2. This one has 5 zeros and then a 6. So this would be bigger. So what is that? That is a red blood cell. So this is the platelet. This is a red blood cell. Okay, and then by how much? So we're just going to take the two numbers and subtract them. So 0.00000 0.006 8. We're just going to add a 0 in here just for fun because we have to subtract them because that says by how much. Okay, so this one I'm just going to go ahead and do this one the old school way. So we're going to make this a 10 and take away a 1 here. So 10 minus 3 is 7. 7 minus 2 is 5. 6 minus 2 is 4, and everything else is zeros. 2, 3, 4, 5 zeros, and then a decimal. So that is how much bigger it is. Okay, and then if we wanted to convert that to, so that would be the number in decimal notation. So it's meters bigger. Okay, and then to write that in scientific notation, we just put the decimal place here. So 4.57, and then I moved it over 1, 2, 3, 4, 5, 6 times, so times 10 to the negative 6th. So depending on which way it wanted the answer, either one of those would be correct. So either decimal notation or scientific notation. All right, and question number 5, this is the last one for this lesson. So it says, China and India are the most populous countries in the world. China's population is approximately 1.45 times 10 to the 9th, which I think is 1.45 billion people. And India has 1.4 billion people. How many more people live in China than in India? Well, this one's kind of easy because this is 1.45 billion, this is 1.4 billion, so the answer would be point, yeah, well here, I'll just show you. All right, so we're going to convert this number to standard notation or decimal notation by moving the decimal place over 1, 2, 3, 4, 5, 6, 7, 8, 9 times. All right, and then we are going to subtract 1.40. So it's here. Just going to put the commas in here. All right, and then 0, 0, 0, 0, 0, 0. All right, so we're going to subtract those two numbers. So, of course, that's 0, 0, 0, comma, 0, 0, 0, comma, 0, and then 5 minus 0 is 5, 4 minus 4 is 0, and 1 minus 1 is 0. So it would be 50 million people more. So, and if we wanted to convert, so this is the answer, 50 million. But if we wanted to convert that number to scientific notation, we just write it as 5 times 10 to the, and then so we're putting the decimal place here, and we go over 1, 2, 3, 4, 5, 6, 7. Actually, we went this way because it starts here and goes this way. So 7 times. So 50 million in scientific notation is 5 times 10 to the 7th power. So either 50 million or 5 times 10 to the 7th. Either one of those would be correct answers. One's just in scientific notation, the other is in decimal notation, so depending on which one it was looking for. So that is it for lesson 7. Again, to add or subtract numbers in scientific notation, first step we always have to do is we have to convert them both so that they are both in the same power of 10. And then we can add or subtract them, add or subtract the coefficients from there. So again, the coefficients are the numbers that are out in front of the power of 10. So these would be the coefficients here. I should probably use a color other than blue. So this would be a coefficient, and this would be a coefficient. All right, if you guys have any questions, feel free to book some time with me. Otherwise, we'll see you in the next live lesson. Have a great day.